Hi guys, this video today is going to talk about how to graph log functions. A couple of typos up here. I think yours is already corrected. This should be lesson 8-10. Over here it is not chapter 7. In big ideas we're in chapter 6 and we are calling this unit 8. So just ignore the chapter 7. Let's look at how to graph log functions. First of all, one thing to understand about log functions is that exponents and logs are inverses of each other. And when we have inverses, that means that we switch the x with the y, and it also means that we reflect over the line y equals x. And so I have a couple things set up here so that I can get started. One thing is I drew in my line y equals x. That's the line y equals x. Secondly, I filled in my -2, -1, 0, 1, 2 into my x here, but because the x switches with the y, I'm going to put those same numbers over here in the y column. Okay, let's think about if we plug these in, and we should be able to do this mentally. If we plug this in, 2 to the -2 is 1/4. To the -1 is 1/2. Anything to the 0 power is 1. And then 2 to the 1st is 2, and 2 to the 2nd is 4. So let's take a second right now to graph this. We had been talking about exponential graphs. Parent functions are going to have a point at 0, 1. The next point is 1, and then whatever the base is, which in this case is 1, 2. And on the left, it's -1 and then 1 over that. So it's -1, 1/2. And then we can keep going from there. And this one will be 1/4, and this one will be 4. And so now we can graph this. I might, just because I have a hard time graphing on this screen, I might go ahead and put in a 3 would give me an 8, and a 4 would give me a 16, which I don't know, would be way up here or something, just so I have kind of a guide of how to graph it. So I'm going to fill this in now. Okay, I told you I'm not great on this screen with graphing, so mine's kind of wobbly. But your graph should look a little bit like this. Now, we know how to do that. We learned how to do that last week. Now we're talking about, okay, if I know how to do that, how can I graph the log function? Now, let me also remind you that last week I told you your calculator can do this. I haven't showed you how on the calculator though. So for now, what I wanted to say is let's figure out how to do it from inverses. Again, if this was a normal setting, then when we had a test on this, I would expect you to do this without a calculator, okay? So we're going to switch our x with our y, and we're going to switch the y with the x. So these same numbers over here, I'm going to put them in over here. Usually by the time we get to the test, people start asking, wait, we can't use a calculator? How are we going to do this without a calculator? This is how I do it without a calculator. You have to just think of the original and then turn it around, and that's how you'll get this. Okay, let's take a second to graph these points. Okay, here is our log graph. So I went ahead and plotted my points, and you can see that those are reflection over the line y equals x. A couple other things to notice. Remember we were saying that we always have a point at 0, 1? Well, with logs, we will always have one at 1, 0. And the next point is at 1, 2. Well, on logs, that point's going to be 2, 1. And then you can do the same thing over here. 1/2 -1 is going to be over here. So it's the same pattern in a way. It's just flipped on its side. So this is our new graph. This is the log graph. Couple things to notice. Exponential graphs start at 0, 1, and they go up, 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 up. Log graphs start at 1, 0, and they go up, but then they kind of flatten out a bit. And we're going to talk about that asymptote here in just a second. There's not an asymptote over here, but there is an asymptote over here. So in the original one, in this first equation, the exponential equation had a horizontal asymptote at y equals 0. And then we went over to the log equation, and the log equation does not have a horizontal asymptote. The log equation has a vertical asymptote at x equals 0. Okay, so my vertical asymptote now is here. Sometimes it helps to know where that is to kind of orient yourself of, you know, which way is it going, what's it getting closer to, and what have you. So just keep in mind that an exponential graph has an asymptote at y equals 0, which is the x-axis, and the log graph has an asymptote at x equals 0, which is the y-axis. But those patterns, that's how we're going to do all of these. I'm going to start with the exponential, I'm going to switch with my x with my y, and that'll give me my log. And these same patterns about the 0, 1 turns into 1, 0, etc., those are going to come into play on all of these. Let's go to the next problem. Okay, same problem, and you're going to see how similar these graphs look. Take a minute right now, see if you can fill out this table and graph it. Okay, here's the graph for y equals 4 to the x. It's a little bit steeper, right? And so here's our table. I went ahead and plotted those. We're now going to go in and do the reflection. And really 2 ways you could do it. You could just draw your reflections. You could do that. Or what I'm going to do is I'm going to fill in the table. Okay, once again, here we have the reflection. Here is the table. My graph isn't perfect. I really tried. I got really close to that axis over there. So we have a vertical axis here for the log graph. We have a horizontal axis here for the exponential graph. We talked about asymptotes. Let's take a second to talk about domain and range. Okay, for the domain, remember that's our x values, we can go the whole gamut from negative infinity to positive infinity. The x values will go everywhere. The range, though, we do have an asymptote. So the range starts at 0 and goes to infinity. And it does not include that 0. The range, remember, comes from our y values, and this is going to get closer and closer and closer to 0, but it's never going to quite reach 0. So it's going to have a parentheses there on that. Okay, so that's our domain and range for our exponential function. When we do the log function, do you remember that when we switch the x with the y, that also means that the domain and range switch? Okay, so where we used to have the domain is negative infinity, positive infinity, now that goes to the range. And where the range used to be 0 to infinity, now that's the domain. And let's just look at the graph to make sure that makes sense to us. The domain, remember I said we have a vertical asymptote here, so it goes from 0 to infinity, never touches 0. The range, you can see it's going to go all the way down to negative infinity, and this will keep going up, up, up a little bit towards positive infinity. So those are our domain and range. For now, that is basically all you need to know for graphing. Start with the exponential, switch it up, and move it over to log. In the assignment, there might be a couple of transformations, but those would just be the regular high-vo transformations that we've been doing along the way.